All right, good day guys, welcome again to my channel. I am Joshua the designer, and in this video I'll be showing you something simple about structural detailing. And this video is inspired by one of our amazing followers who asked a question via the comment section in one of my previous videos. He said, "Hello sir, thank you for these amazing videos. Could you please do one for staircase, column in a story building, footings and retaining wall?" And in this video I'll be taking only column in a story building, while in subsequent videos I'll be showing you some other structural elements, and I'll be using one of those structures as a case study today. One of the structures I took on in my internship period. I've been speaking about internship in the last few videos, and I'll show you one of those videos that one of those structures that I designed solely during my internship period. And this video is going to be focused on the structural detailing of a column in a story building. So stay with us as I show to you how to go about this. All right, so this is the picture of the building I designed, and while in construction. So we'll be picking one of the columns as in a reference to show to my subscribers how to detail a column in a single story building. All right, so we'll be picking one of the columns as in a reference. This exactly will be the column we're going to deal with, column 4A A1. All right, so this column is a 25 by 25 column. All right, this is the foundation layout, as you can see on my screen. This is the first floor layout, as you can see, and then we have the roof layout where the column terminates here. Also, we have the general section, which shows you the intricate part of the building. Okay, so we have also section 2.2 that also shows us a section across the building. All right, to go about doing a column elevation and then the column detailing, before you can go ahead to have something like this, which is exactly represents a column detail for a structure like that in request, you ought to first understand that you need to come up with a column elevation that shows exactly what the column looks like. Then you can go ahead to place your reinforcement accordingly. And as you know before now, that the way we do it is we go about using the standard method of detailing, so that you can get accustomed with the proper and the right foundation of detailing. Okay, so if you would like to use this text wherever I have it in my previous video, go there and check for the link that has the folder for the standard method of detailing in my 10 books that I suggested for any structural engineering students. All right, so let's go ahead. We are dealing with this column, which is the same as this column, and then the same as this column. So one question you need to ask yourself is this: what is the floor height? So as you can see in this general section, for example, of that building that you just saw, we have 3.6 meters for the ground floor, and then 3.5 meters for the first floor. So what you're going to do is this: you are going to represent what you have on plan into an elevation. Okay, mind you, before we go ahead, let me show you what the standard method of detailing manual looks like. Okay, so this exactly is a standard method of detailing, and then it contains the code and the design informations with which you ought to abide by, so that you can have a good detailing and a good structure by so doing. All right, so we're coming back here where I'm going to show you certain things that applies to our work. So let us first come about our elevation drawing. So we want to first create a datum which represents a reference, maybe a floor, ground floor, or natural ground level, or the finished floor level. Just create one of those. You can start with the finished floor level, you can start with the natural ground level, another can start with whatever it is. So I want to start with a finished floor level. All right, or natural ground level. So from what we have there, we have 3.6 meters. Okay, 3.6 meters. That's the ground floor. And for the first floor, 3.5 meters. So I have an offset that says 3.5 meters. Okay, now I want to draw the the length of the column itself. Okay, so if this represents the ground, nothing goes beyond. Okay, and if this represent the roof, that's the limit of the height, nothing goes beyond. And like I said earlier, that the column itself is a 225 by 225 column, so we have 225, and that shows the width of that column. Okay, and because it's a column, we want to make sure that these guys don't extend unnecessarily. So let's put it this way. Okay, so whatever it is we want to express with those lines afterwards, we can, but for now it shouldn't be excessive. Okay, now that we have this, you look into our plan. On the first floor, you discover that what we have here is a column behind. Don't forget that this is the column we are designing. This is a column we are trying to draft out the information. Okay, so we are having a beam right behind that column, not visible at the approach, all right, but is behind. We also have a slab that rests on that particular beam behind the column. Okay, so what we want to do is to try to represent those things in our elevation drawing. Okay, so what we want to do is just offset this to be 450 downward. Okay, then not forgetting that it only appears behind. Okay, it has no extension to the right or to the left. Then in your detail, you may just try to make this in expression a dotted line or a dashed line, okay, or hidden line, most preferably, all right, or and you make it a very faint line because it's not obvious to you at the approach. Okay, so do not forget we have a slab that is directly connected to the beam, or a 150 slab connected to the beam. Okay, so we have 150 and it's not directly connected to this column but the beam behind the column, so we just trim the length of it. Okay, then on this, in fact, we may not show this way, okay, because it has no business to do with this column in particular. You may just want to be too detailed to make this happen, all right, which may not be too necessary. So if it happened that the column, all right, is directly connected to the beam, to the slab, what would have happened is that we have this, which illustrates that your column and this slab will be cast together, or they are in a single unit. I mean, the beam and the slab are as in a single unit, but we can just leave it this way since it also represents that. But looking it into more closer detail, this exactly doesn't tell us the information. This doesn't really show that information. Okay, so in my best interest, I would have said, okay, just let us seal this up, so when they get to site they understand better why we have to seal this up, because it has nothing to do with that slab directly. You see what I'm saying? Okay, but thank God I've explained that, you understand why it is like that. Now the next thing we want to do is to get to the roof. What happens on the roof? We have the beam connected behind and then towards the left. Then you have to represent that in your drawing. So, and that beam is a 300 beam, 300 by 25 beam, by 450 beam, or by 25 beam. It could be 300 by 300 depending on the engineering judgment and your design considerations. Okay, so we don't have continuity on this path. Do not forget, so we can just trim it off. We have continuity on this path, so you might just retain something around that path. All right, so we're good with this, except for the fact that I may need to use an extension to show the levels here. All right, to show the levels. Okay, let's put some details that makes it relatable. For example, the height of this is 3.6, like I've said. Okay, then the height of the next floor, 3.5, just like we have seen um in the other drawing. Now I just want to match a little property here so that I have a very good figure. Okay, great. So we have the depth of our beam at this point 300. It looks bigger, then I like to match the property. Then the length, the depth of this beam also, which is this. Okay, so if you care about the thickness of the slab, you may put it. You just ensure that your column gives enough details. Your detail, your structural detailing gives enough information on whatever it is that you're doing. Okay, so please ensure that you have a deep knowledge or deep information of what you are trying to carve out, so that your detailing can be expressive. So someone can get to look at your detailing and one at once understand what to do next. All right. So to put further information on what we have the roof, and then we have the first floor. You see that now? We have the roof here and then the first floor. Okay. Does this fully represent what we have over there? So if you look at this, this is how we started it. So this is how it started. Now let's continue. What is the first thing I'm going to do? And this is where we need to consult our structural standard method of detailing. Okay, so let's get there. Design code requirements. So we have the minimum area to be 0.4% of the cross section, the minimum size of bar to be 12 mm, and these information are very important for you. Then the next one should be minimum number of bars, which is supposed to be 4 numbers in rectangular columns. All right, minimum number of bars, 6 numbers in circular columns. Minimum area if vertically cast, 6% of cross section. Maximum areas if horizontally precast, 8% of cross section. Maximum area of laps, 10% of cross section. Minimum overall juggle offset, I'll show you that what it means as we go on. 10% of cross section. Minimum overall juggle offset, 2 multiplied by the diameter of bar plus 10% tolerance. Maximum juggle length, 10 times center line offset, or 300 minimum. And the last one, allow 75 clearance above lower bar to start off juggle for tolerance. You see that now? So how does this affect our detailing? Let's get to business. So the first thing that I would like you to understand is the what we call the splice. So before we go ahead, let me just show you here what we call the splice. So once you get here, you see column elevations. Column elevations. We have what we call column elevation. So looking into this column or bar intersection, wherever you have a column or a beam intersection, sorry, a column or beam intersection, or where you have a reinforcement connecting with another reinforcement coming from another level. So there is a need to provide a splice bar that connects to individual bars, because you can't just leave a bar jumping into another without connectivity. All right, so it allows for the connections of the stresses, or the transmission of the stresses. All right, so we need the splice bar. So the splice bar is what you can see safely just down here after the kicker. All right, so the kicker comes before we can cast another length or full length of columns, all right, on a new floor. So we have a kicker, then after the kicker, or the splice actually connects from the lower floor onto the next floor. All right, then it transmits the stresses into the next one. You see that what we're talking about? So let's get to work with this knowledge that we have now. Okay, so getting into our drawings now. Now remember that this floor below is a ground floor. Now you have the foundation footing, all right, below this floor. The footing, the foundation used in this project is a pad foundation. Okay, so you have a pad foundation, and there's a reinforcement that connects the starter bar. We call it a starter bar, all right, that connects that foundation to the ground, to the first floor columns, or the column that connects the ground floor to the first floor, which is this. Okay, so how do you do that? So we have about if this is a column and the reinforcement starting from a floor below or from a level below, which is the foundation footing. Okay, so that's what I call the starter bar, which exactly you see we have here. And do not forget, I spoke about the kicker while I was starting. I said the kicker is a small or a thin thickness of concrete that we have before would have an overall cast to the next level of the column. So from the standard method of detailing, there is a recommendation. Um, as you can see here, you have seven. Okay, this is actually not that. Kicker height. This is general design information. Now here you have kicker height, otherwise assumed as 75 mm. So that's what we're going to stay with. So offset 75 mm from there. You'd have the kicker. You see that? Now from this kicker, you can begin to have your lap length. So the lap length is basically the sufficient length with which you can begin to lap one reinforcement with another to transmit the stresses. You see that now. So that's very important. Now looking at this, you see how it is being done in different scenarios. In different scenarios. So let's see if we can find any information as touching that. Okay, so let's still go on. I'll show you as we go on. Now to have another lap that continues this reinforcement from this level, we'll need to make a little calculation. All right, so if we are using a 16 reinforcement, for example, if you are using a 16 for example, to find the lap length, the sufficient lap length for this reinforcement to transmit the stress, we are going to use 50d, 50 multiplied by the diameter of the reinforcement, which is 16, which that's 800. So from the kicker, you offset 800 from there, it takes you there. So this is the minimum, is actually a minimum length of this SATA bar that should get into this unit of column at that height. Okay, so for transmission of stresses. So from there you can begin to have the connection at that point, which is sensitive. Now you have to pay attention to what I want to do here, and I'll show you from the standard method of detailing. Okay, looking at this now, this is exactly what we want to achieve at this point. Now there is something we call the juggle offset. Juggle offset. So from the face of your reinforcement to this bend, all right, is what we call the tolerance. The tolerance that you had exactly with the diameter of the reinforcement, then you have your overall juggle offset. So we have 16 reinforcement, for example, multiply by 2, that's 32. 32. So 32 plus 10% tolerance, okay, which is less than 5 that's about 3.2, which is less than 5 so we can have 37 which we want to round up to about 40 so let's try that out. So from the face of this, let's assume we're having a new bar and an offset of 40 now this offset is supposed to be the continuity of lapping, all right, down here. Okay, now we have achieved that distance. We have achieved the distance. Now let's go ahead to see what next. There is a bend and there is an allowance. Allow 75 clearance above lower bar to start of juggle for tolerance. So this is what we're going to do. From this lower end, where this stops actually, you offset 75 mm. Okay, and this is where the juggle starts. This is where the juggle starts. So everything you are doing should be apart from this. You see that now? 75 mm. So we are following step by step. Now from the 75 mm, we can now connect to a distance. And what is that distance? The minimum juggle length. Then multiply by the center line offset, or 300 mm minimum. So what exactly you are supposed to do is to find 300 mm minimum, all right, for your length. So what I just want to do is to, and don't forget, it's not a linear length, it's a diagonal length. Okay, so we have where we're supposed to start from, which is here. Then 300 minimum on this. I might decide to use maybe 400, but let's stay with 300 minimum for this lesson. Okay, which is this. So it's going to be more like this. So let me have my line from this point, and 300 minimum. So we have this. I can trim it off now, or I can maybe join this together and take this away. So you see what we have now. You see what we have now. So this is what the code recommends for us to use. This is what the code recommends for us to use. Now, this can be a new reinforcement. Then you repeat what you've done down here, repeat at this new level. It makes sense that way. Okay, so let's do another kicker at this point. Just like what we did here exactly is what we're going to do up there. What we did here exactly is what we're going to do up there. So we have this as a new reinforcement connecting with this one. It's still a single reinforcement, So this is a single reinforcement. This is a single reinforcement. You see that now? And do not forget, the cover to reinforcement for column is a minimum of 40 mm. So you see that we have minimum of 40 mm here. All right, from the face of the concrete column. Okay, so we have a single bar spanning just this way. All right, which laps at this point to connect the stress. And the lap length, as I showed you, 50D from here to this place, 50D. You may want to match the properties. Okay, the same thing for the upper floor, where we have this also. Okay, then repeating the same thing for the next juggle that we're going to do. Since we are dealing with the same diameter reinforcement, we just have to copy what we have here. Then if there be any amendments, we'll create that at that level. So you should know how this forms now, how this comes to be in. Okay, now this level is the roof, so everything terminates at this floor. So I just want to create a cover at this point, which is cover of 40, then create a fillet around this point to show that it ends. Then I can have a little anchorage at this end. So this shows what my reinforcement will look like. All right, so from my design, it is said that 4y16 should be at this level, 4y16 reinforcement. All right, so I have 4, and I told you, as said in the detailer's manual, it says that the minimum number of bar for rectangular column is 4. All right, for circular column is 6. Okay, so and that's why you're having 4y16 for a circular column, and the same thing applies just up here. But seeing that we're having different length, so they can't have the same bar mark of reinforcement. So we have 4y16 O2. Okay, so that's how we have this. Now we can just try a little more to put the links reinforcement, yes, the links detail, so which we call the stirrups. So we have from here about 50 above the face of the kicker. All right, we can have our stirrup just there. Let's just do 50 okay, this line seems not to be too straight, so create a straight one and delete this. Do not forget to keep your properties bold and clear enough. Okay, so I'll make all my steel bar properties bold and very clear. And this. Okay, what next? So if my stirrup starts there, then it's going to end somewhere at the end, other part. So I can just copy what I have here, then knowing full well that it ends somewhere here. So it's going to be somewhere here. So like I said, this place is subject to whatever condition is happening on your site. So in this job, we discovered that this column stands alone, and this slab is way behind the column, as you can see in that plan, on the plan and in the picture. Okay, so this can go right there. Okay, it goes above that particular floor. Okay, so what we have now, let's just keep it this way. What we have next is to put the information of our links, as you can see in this that we use there. Okay, we have whatever it is here. So I'm just making this as simple as possible for you to understand. So whatever it is that we have here is showing how much information. Yes, so this reinforcement, we have a beam here, so it stays below the beam 50 below the beam. So there's a beam here, do not forget that. Okay, so how do we know this is 18? The span of the stirrup, which is 2975 in my calculator, all right, divided by 175, which is the spacing, recommended spacing from the design, and that's 17, plus 1, that's 18. So the same thing applies to the upper floor, apart from the fact that the length there is a little bit smaller than this. Let's see if it's the same that we have there. So we have this. Okay, so this is, let me take this to the appropriate position. This is 3025. Okay, so we can just have 3025, and that's 18 also. So we're good on that. So the last thing we want to do is to have our sections, and I'll just copy that and show you what I'll just explain to you with what we have already, how you can go about to make your own. Okay, so we are defining a section across these planes. Section 1-1. This represents section 1-1. And now the section shows that our column is 225 by 225, and then we have 4 numbers of Y16 reinforcement. Then the stirrups you're seeing here is exactly what you're seeing round about this. All right, with this information. The same thing happens here, 2 divided by 225 column, 4Y16, the stirrups, and the respective information. All right, so this exactly shows how we have a column elevation and column reinforcement detailing for a single story building. All right, now you may look in comparison with the building that we have while we started and see how we came about it. If you have any questions, query, comments along this, do well to drop that in the comment box. as I'll be there to answer you. So if you are new to my channel, this is where you should be. Use the subscribe button, like this video and share it to your friends that should get better with structural engineering. Hang on. See you in the next video. Bye.